Okay, so that concludes our chapter for the chi-square distribution. So let's just go ahead. 11.5 is just reviewing the three type of tests that we have. So the comparison of the chi-square test, right? We have three. The goodness of fit, it has, let me note right here. In the calculator, right, you put in list 1, right, and you see if L2 is the expected, so one's the observed, one's the expected, right? And then you go ahead and do the chi-squared Goff test. Okay, but when do you use it? To see if a distribution is a good fit. That's all. And usually it says good fit. It says, does it fit the distribution? Does the distribution the same all the time, right? It's just about a distribution and it being a good fit. The independent is when they take two categorical variables and they will use the words independence. Like, are these two independent? Is gender independent from a response? So this one, again, you would use in the calc, put it in a matrix, right? Expected, observed. Expected goes into, remember, the empty matrix, and you use a chi-square test. And you are testing whether the categorical variables are independent. The row and the column are independent to each other. And be careful with the claims, right? In this case, in our example with independence, the claim was our null hypothesis. So always identify the claim after setting up the hypothesis. The last one was the test for homogeneity, and that's essentially the same. You're testing independence, but within proportions, but we call it homogeneity. And it's just a way of testing more than two proportions, right? At least three or more. And so again, notice that the null and alternative is either the population proportions, right? We had P1 equal P2 equal ... all the way to however many samples you have, right? N, right? Either they are the same or they're not, right? At least one is different, right? And so there you'd use the same exact process as testing for independence, because you really are testing independence just for proportions, right? So calculation in the calculator would be, you put it in a matrix with observed, and then you leave or you choose an empty matrix for the expected, and then run a chi-square test on the observed matrix. And again, the most important thing is when you set up your null and alternative hypothesis, do that first. Then determine the claim. Because when you get to step 4 and you're going to reject or not reject the null, that your interpretation in step 5 will discuss in terms of the claim. And if the claim was the null, then there's not enough evidence. So, or there is enough evidence. So you need to make sure that the claim is marked first after you write the null and alternative hypothesis. Okay.